Hello everyone, welcome back to my channel. Today we'll be solving Leetcode problem 2033. Minimum operations to make a uni-value grid. Okay. Problem statement states you are given a 2D integer grid of size m by n and an integer x. In one operation you can add x to or subtract x from any element in the grid. Okay. Let's say this is the grid and it contains these elements, and let's say x is equal to 2. Okay. So you can add to this particular number as many times you want, or you can subtract as many times you want, okay, for each element. But the goal is to make all the elements in the particular grid to be equal. Okay, so here what we can do, here we can increase 2 by 1 time x, which will become 4, and we can decrease 6 by 2, which will become 4. We can decrease 8 by 2 times of x, which is 2 times of 2, which is 4. That means 8 minus 4, which is 2. So that as a result all the elements will become equal. Okay, the idea is to minimize the number of operations required to make the grid as uni-value. If we are not able to make it, that means we have to return it as -1. Okay, let me jump back to my notepad or editor and let me try to explain over there. Okay, so we have been given in the grid as 2, 4, 6, 8. Okay, so this is the grid which we are being given. Okay, so it doesn't matter whether it's a grid or not. In the end we have to make all the elements as equal, right? So let's try to flatten this. Okay, let's say we have 2, 4, 6, 8. Okay, so we have 2, 4, 6, 8. Okay, so idea is to make all the numbers as equal, right? So I can make all the numbers, and we have also given x is equal to 2. So that means at any value, okay, we can increase it by multiples of 2, or we can decrease it by multiples of 2, right? We can, here also we can increase by multiples of 2, or we can decrease by multiples of 2. The same holds for every position. Okay, so let's say I have increased in the first position, I have increased it by one time. Okay, so it will become 4. Here I choose to not to increase or not to decrease, so it will remain as is. Okay, at 6 let's say I choose to decrease it by twice. Okay, so that means it will become 4. I choose to decrease it by 1. Okay, so it will be 6 minus 2, which is actually 4. Here we have choose not to decrease it, here we have choose to increase it, right, in the first element. So for the last element, let's say we have choose to decrease it by twice. Okay, then it will become 4. Okay, so this is one possibility. Okay, so here I have made all the elements equal to 4. Okay, I can also make all the elements equal to 6 as well, right? That is also possible. So if I have to make 2 equal to 6, then I have to increase it by twice, then I can make it 6. For the second element, okay, which is 4, I have to increase it by 1, which will become 6. For 6 I don't have to increase by any value, so it will be remain same. For 8 I have to decrease it by 1. Okay, so if you see, here I have made 2 operations. I have decreased it by twice, here I have increased it by twice, here I have increased it by 1, here I have not increased anything. So total number of operations in this case is basically 2 plus 1 plus 0 plus 1, which is actually 4. Okay, here the total number of operations we have done is basically 2. In the first case we have increased it by 1, right? So it will be 1 plus 0 plus, here also we have increased by 1. We have done one operation, here we have decreased by 2 times, right? So here it will be 4. In both the cases the value is turned out to be same. Okay, let's say we want to make all the numbers equal to 8. Okay, so in that case I have to increase the first number by 3 times, then it will become 8. I have to increase the second number by twice, then it will become 8. First number I have to increase by 1 time, then it will become 8. For 8 I don't have to do anything. Then so here 3 operations in the first case, 2 operations in the second number, 1 operation for the third number, and 0 operations for the last number. So as a result, here we require 6 operations, but if you see the minimum number of operations is 4, so idea is we have to return 4 in this case. Okay, so how can we do this? Okay, so firstly, um, for any given input, right, let's try to sort it and have it in the sorted manner. Okay, so now that I have sorted all my elements, and this is how my sorted array looks like, right? So idea is, see, the thing is, either I can bring all the elements uh, equal to this, that means I have to do some operation from here, some operation from here, some operation from here, some operation from here. If I choose to make all the numbers equal to 4, that means I have to increase 2 by some operations, decrease 6 by some operation, and decrease 8 by some operation, right? If I have to make it as 6, then I have to increase these two numbers by some operation and decrease by some operation, no? So no matter, like, here we have 4 elements. Okay, let's say we have 6 elements. Okay, let's say we have 6 elements, 2, 4, 6, 8, 10, 12. I'm just taking some input. Okay, and this is also is in sorted manner, right? So here, if I have to make all the numbers equal, right, so idea is to, like, this is one possibility, right? And this is also, I can make 2 equal to 6, 8 equal to 6, 4 equal to 6, 10 equal to 7, 12 equal to 6, right? So, or I can make 4 equal to 8, right? If you see, the minimum cost will always occur when we are trying to make all the numbers equal to the middle numbers. Okay, any one of these values. Okay, either I have to make equal to 6 or equal to 8. If I have to make equal to 10, they have to make all these operations and this. Okay, this would actually cost us more than we making equal. Here we have making 3 and 2 choices. Okay, here we have making, here also we'll be making 3 operations from here, 2 operations from here. If I choose to make all numbers equal to 6, from here I have to make 2 operations, from here I have to make 2 operations, but the magnitude, if I have to make all numbers equal to 12, the magnitude would be higher, because this has to reach 12, then the number of operations required will be more. Okay, but if we choose to come from both right and left, right, if I choose to make 10 equal to 6, 12 equal to 6, 4 equal to 6, 2 equal to 6, and 8 equal to 6, the magnitude in this case would be less. Okay, so that is the idea. We have to make all the elements equal to the middle elements. Okay, so either I can choose this or this. In our case, we will be taking this leftmost element, which is 3, 0, 1, 2, 3. We will be taking 3. Okay, the length of the array is 6. We will assume that the median, which is the mid element, as 6 divided by 2, which is 3. We will consider this as the median. Here the array size is 4. 4 divided by 2, which is 2. We will take 6 as our median. Okay, the idea is to make all the elements equal to the median, right? Here, if you observe, we can only, if x is equal to 2, then I can only make, that means all the numbers should have the same amount of remainder, right? Let's say x is equal to 2, so 2 divided by 2 modulo 2 should be equal to 4 modulo 2, 6 modulo 2, 8 modulo 2, right? Then only I can actually make this equal to 6, right? If 2 modulo 2 and 6 modulo 2, if both are equal, then only I can make. Okay, then only I can make 2 equal to 6, because I can multiply 2 by 2 times, and then I can add it to 2, and then I can make it as 6, right? Similarly in the case of 4. Okay, 4 modulo 2, which is 0, right? Then I can actually add 1 to it and make it as 6. Okay, so if array contains all the even numbers, right, then we can transform it. If array contains all the odd numbers, then also we can transform one element to any one of all the elements to the mid element, right? If there are combination of both odd and even numbers, then we cannot transform the array to all the equal levels. So if you take this example 1, 2, 3, 4, okay, here it contains both odd and even numbers. Okay, so here x is actually 2. Okay, so x modulo 2, here the remainder is 1. Let's have remainder here. Here remainder is 1, here remainder is 2, here remainder is 1. Okay, so if we try to make all the numbers equal to 3, that means I have to add some factor of 2 to 2 in order to make it 3. There is no way I can make 2 to 3 by adding any multiples of 2, right? That's not possible, right? So if it contains all even numbers or if it contains all odd numbers, then only we can do. If it contains both even and odd, we cannot do it. Okay, so that is, in that case we have to set our return -1, right? So let's try to code it out. Okay, yeah, I hope my example is I think I've switched the screen. Okay, let me re-explain you. Okay, if it contains both odd and even numbers, we cannot transform the array no matter how many operations we do. Okay, this is one such example where we have 1 2 3 4, okay, and x is equal to 2. Okay, let's say we have to convert all the elements to 3. Okay, so 1 plus 2 will be 3. That means I can convert 1 into 3, but can 2 be converted into 3 by adding any factors of 2? It cannot be, right? 2 plus 2, which is 4, which is higher, and 2 minus 2, which is 0, which is lesser. There's no way we can reach from 2 to 3 by adding some factors of x, right? So it's not possible. So that's the reason we'll return -1. Okay, if array contains both even and odd numbers, then we will straight away return -1. Okay, if that's not the case, then we'll try to identify the minimum number of operations required. Okay, so I'll jump back to my Leetcode and let's try to solve this. Okay, so as I mentioned, okay, we'll first try to flatten the array and then we'll try to sort it. Okay, while doing this uh, task, we'll also check whether all the elements are even, like the remainder of all the elements with the x is equal or not. Okay, if it's not equal, that means it contains both even and odd, right? Yeah, so let's have uh, the number of rows, which is m, is actually grade dot length, and n is equal to the number of columns, which I can take grade of 0 and length. Okay, these are the total number of elements in my entire grade would be m times n. These many elements will be have. As I mentioned, I will also flatten the array. So we'll have the flattened array as nums, and the size would be equal to n, which is m times n. Okay, now the idea is I have to iterate through the grid. Okay, and then I should populate my nums, and I should also check whether the remainders of all the numbers is same or not, right? If nums modulo x, if it is not equal to grid of 0 0 modulo x, that means all the numbers have, that means there are few numbers whose modulos are not actually matching, then I will set a return -1. That means it cannot be transformed into the same values. If that's not the case, then I will basically add the current number to my nums array. So let's also define a variable called int I equal to 0, and then I'm adding all the elements into my nums. Okay, as I have mentioned that we'll also sort our nums, so the sorting part is also done. Okay, now that we have sorted the array, now that we have to identify the median and then try to identify the minimum operations required to convert each element to the particular median, right? Yeah, so let's say the median is equal to nums of n divided by 2. Now that I got the median, right, let's say int operations is equal to 0. So I have to traverse through my nums array and then for each number I should basically identify the operations required to convert it from nums to median. Okay, so if I have to convert 4 to 6, that means I should add 6 minus 4 divided by 2. Now those many times I have to add x to the 4, right? So it's basically median minus the current number divided by x. This will tell me that how many times I have to add x to the current number in order to make it as 6, in order to make it as the median. Here median is 6, 6 minus 4, which is 2 by 2, which is 1. That means per 4 I have to add 1 2 in order to make it as 6. Okay, here if you see I have added 1 2 to 4 in order to make it as 6. Okay, so that is what we are doing over here. So if the existing number, if median is higher than the current number, then it will be a positive number. What if the median, the current number is higher than the median? That means we have to take the absolute difference, right? So that's the reason. Let's also have the absolute value of median minus nums, and then we'll divide it by x, and then we'll add it to our operations, and then I will return my operations. Okay, so this will be the total number of operations required, right? So let's try to submit this. Yeah, default test cases were passed. Let's also try to submit our solution. Yeah, all the test cases were also passed. Okay, so yep. So if you observe, like, the time complexity in this case will be the time complexity taken by the sorting, right? So depending upon the algorithm which is getting implemented, the time complexity will be n log n if it is merge sort, and the space complexity would be order of n if the sorting was implemented using merge sort. Okay, and this is basically the linear time, like we are just iterating through the array and then trying to identify the operations required, right? So this is single iteration. So the overall time complexity will be order of mn, which order of n log n, where n is basically m times n, right? So yeah, that is the overall time complexity. Do subscribe to my channel for more such coding videos. I will be posting one coding video every day, right? Thank you.